So till we get the formalities ready, hello everybody, my name is Andrei Ene, I'm from the Romanian delegation from the Technical University of Civil Engineering, Bucharest. I shall be presenting a very beautiful project. As my colleagues from Romania mentioned, they participated in 2018 at the Federation of European Heating Ventilation Air Associations, RIHVA, the annual student competition that they held, and this is the work with which I participated in 2014 together with my colleague, and we actually managed to get the prize for best work. And even though some years have passed over this study, the truth and the core of this project are still real. The problems indicated here are still present, and I also enjoy Mr. Milanovic's piece because at one point they are very related, as you will see. I started this project together with my colleague Nicolae and Andrei. I was a couple of kilograms lighter here. And my dearest teachers, Mr. Tiberiu, CATALINA and Razvan POPESCU. A quick break here. I was a member together with Nico of the Romanian team Solar Decathlon Europe, as one of the members of the board mentioned, and quoting them, join and engage. It was a very beautiful experience. Look it out. You must participate to a very full experience for a student in our domain at least. So we all heard about energy efficiency. We are all working on it, and also indoor environmental quality is a top subject in these days. But what we try to address is the interconnection between these two subjects, and moreover, not in just any other building, but as you can see, in a particular building that helped us, each and every one of us, at the beginning of our life. But we all had some problems at one point. We started this program, we started this project from a European Union's agenda, a directive from 2010, a very important directive, the 2020, and we tried to go on the principle of reducing the energy consumption with 20% of a building and the building services, and also reducing the production of carbon dioxide by 20%. Before getting more into the subject, I want to mention that we started this project by addressing a very simple question: what is the true purpose of a building? Why are we building it? If not to provide a healthy and efficient indoor environment for humans. This is the main goal, if it's a residential, office, industrial. And we forwarded our attention towards educational facilities. We're talking primary, general, gymnasium, high school. It is one of the points that marked all of our lives, and as you can see, and it is known, 25% of our life we spend it inside the school. And there were, at least on our market in Romania, we found too little assessment of the indoor environmental quality in these buildings. So we turned to this interdisciplinary topic with intriguing aspects. It is very important to mention that we managed to fulfill, at that time, a unique project in Romania, a full and complete assessment, not only on a classroom, but on a school, with both experimental campaigns, us, the students, on the field, taking measurements, putting the equipment in place, arguing with the teachers and parents sometimes, and also the numerical simulation, the softwares that have to take us from the from a phase to another to help us to evolve much faster, as you will see in our work. So the main goal was to try to reach Class A building for both energy efficiency and also indoor environmental quality. At the end, you will see that we managed to conclude with points of view from a micro point of view to a macro point of view, from the simple classroom to a school, and you can apply this to most of the schools in our country. It was a complete experimental investigation. 12 different schools, 9 different cities, a lot of work, months of data. We gathered surveys passed out and filled by more than 700 pupils. We managed to install in all of our prototypes classrooms all of the necessary equipment to gather parameters such as temperature, humidity, illuminance level, and acoustic level. A full analysis on the indoor environmental quality, the 4 parameters that stay at the base of a high quality indoor environment. We locked on one single project because we had to go on with a full-scale project, School Jose Marti from Bucharest, Sector 2. And moreover, we turned our attention towards a classroom at the first level, and this is where we developed the rest of our project. Now, it is after we installed the equipment here, and after weeks of data analysis, the conclusions, we kind of already knew them, but let's go quickly through them all. We have poor illuminance levels. We are talking about schools in Romania, schools from the first grade towards the 12th grade. The minimum of 300 lux was not met in this classroom, and neither in nearby classrooms. We are talking about overall 186 lux. These are measurement points established by us, the students. It was our work in the field. For the CO2 levels, we had a grid 3x3. We had 9 equipments, data loggers, that they managed to log data for weeks and time. And here you see just one single day from 7 o'clock to 4 p.m. You can see levels of 4,800 ppms, which is huge. And this we're talking about in a room full of 20, 30 children, in our case 28, if I remember exactly. Of course, plus the teacher we're going towards 30. Again, another problem we had with air temperature levels. As we already know, and it was pointed out by other works. And I'm going to give one particular example that we found back then. The United States of America, a North Carolina project, they did an analysis on their school, and it was proved that the efficiency of the students, just by improving the luminaires, the lights, to have the 300 lux, the efficiency raised with 14%. We are talking about their grades, we are talking about how they evolved in a period of time. Now, we got the data, we had the equipment, but we needed the innovative approach. We wanted to emphasize a full-scale project, so we turned toward the fundraising campaign on our own, and we managed a breakthrough when we got the ventilation unit with a heat recovery unit installed. A simple ventilation unit with a heat recovery equipment. We managed to install it in safe conditions, as you can see in the upper right corner. And also here we presented the other high precision equipment that we use, Testo 480, Bruyère technology, the CO2 meters. Quick information about the air ventilation unit. The maximum capacity was around 1,000 cubic meters per hour, with an efficiency of 90%, but as you will see, we did not use that level of power. Now that we had new data with the ventilation unit installed, we need to go to the software and evolve our work, not only to assess the actual state, but to propose solutions, concrete and effective solutions. For this, you have to design. You have to sit at a computer and use the available software to better enhance the project. So we turn towards Dialux for illuminance improvements, Odeon for room acoustic software, Transi 17 and MATLAB Simulink with the Meteonorm database, of course, for Bucharest, for that specific period of time that we analyzed. Moreover, we did not just place a box inside the softwares, we took as much as possible of the characteristics. The thickness of the walls, the number of pupils, the clothing factors, the heat gains from artificial lightings, and many, many other. The first parameter we attacked with the experimental campaign now at the software campaign, the analysis, was the illuminance level. These are the values from, on the left you see the values from the experimental data at night. What is the illuminance level of a school in Romania? At the right side, we calibrated the model. We have a model in the ALUX, and after you complete your room, as you can see in the lower left corner, you have to calibrate it, make sure you have the surfaces right, the geometry right, and we managed to succeed. Now we were able to go on forward and think of energy consumption reduction, but there was a problem. Time. When you're talking about illuminance level, you have to take the exterior lighting into account. And in DIALUX, when you want to do this, in our school that we have built, in our classroom that we have built, we took 5 minutes per simulation, way too long. So we brought an original approach, our approach. Nico had the ingenuity to find a piece of work from a colleague from Slovakia, if I remember correctly. It is an Excel that includes DIALUX data with Krugman equation, plus a correlation of outdoor and indoor illuminance levels. It had precise data, we checked it out. So, moving on, we got the lighting factor from DIALUX. We did Excel. We managed to find the illuminance level inside our classroom, in our specific classroom, at all 88,760 hours of the day. Now that we have this data, we can check it up when the light levels are under 300 lux, and we implemented we can activate the lighting, the artificial lighting system, with the proposal, of course, of LED luminaires, and with actual data, with calculus, we have a reduction of 30% of the energy consumption. So what appears like a simple calculus, it has many, many hours of work, days of work beside, and you get to a simple conclusion. You only need 1,000 hours, 645 hours of artificial lighting. Thus, you can make an estimation at the end, as you will see on our final slide. We went on to the second parameters, the thermal comfort. Again, we had to build our room in software, a beautiful software, a very hard software, Transi 17, but I loved it. And here is where we took into consideration the time step of 0.1 hours. We found a very good match between the simulations, between the project. You can see the scheme ups there, up. And the measured data, we managed to calibrate the module again with maximum errors of 6.9%. And now we can go on with the future of simulations, as you will see. This, from my point of view, is one of the most important slides, because it's the result, represent all the results from the questionnaires, from the pupils and the teachers. What happened before and after the ventilation system? A simple ventilation system that now we do not have in the schools. You can see 38% said is a lot better about the temperature, about the indoor air quality, that smell during the hours, and that environment, a lot fresher than yesterday, 40%. And another 52% is fresher than yesterday. You can see that the results are positive. If we were to talk about indoor air quality, we did not leave this subject aside. So, with our data loggers, we managed to get the data. What did we do is turn on the ventilation unit. You can see on the left, with no ventilation on, values of 5,000 ppm. And inside the same room, you have differences of 1,200 ppm. This is huge. On the on the right side, you see the ventilation unit at 25%, 250 cubic meters. How the maximum level goes down to 2,500. It's still large, it's still huge, it's still big, but it is at half. And the differences inside the room reduced only to 470. I have here a short rudimentary scale. On the left side, you see with the ventilation on 25% what's going on inside the classroom. On the right side, with no ventilations. This is the ppm values inside that classroom in a grid 3 by 3. So every day, myself, I'm sure I was in this situation, many of you, our pupils are staying in this kind of conditions. Of course, until the recess comes and some of the areas transferred and when the windows are open, with a great loss of energy. Because we had some problems and we had some issues with the noise levels at that moment, because the air unit was not acoustically sealed, we had to turn over to a software to see what happens at higher rates of air refresh. And we turned to MATLAB Simulink. We managed to create a model, and we managed to obtain an equation. We calibrated the model. It's the same values. This is an important word, to calibrate the model, not just to import the data, to make sure that it is correct with minimum errors as possible. And we managed to obtain an equation. What do you need, as you can see in the upper graph? What do you need to bring, according to the European norm 15251, a category 3 classroom, 17 cubic meters per hour in person? You will reach that 480 cubic meters per hour by that ventilation unit. Again, you have the simple result, you know how to apply it, we just have to apply it further on. The fourth and the final parameter, the acoustic one, is also very important. Sorry for that. We had the good sound pressure levels inside. The time reverberation was a little high, 1.3 seconds. A good sound pressure levels because usually the schools are placed in green areas, away from the cars, highways. But again, problems occur when you design a project. You stumble upon something new. When you turn on the ventilation system, of course, you got a new source of sound, up to 55 decibels. So, again, we turn towards the software. Odeon Room Acoustics software, a beautiful software. I never thought at the beginning I was in a third year of faculty, I never thought I could execute it, but we managed to create the model, we calibrated, and we went on to simply design simple materials you can find on the market to reduce the reverberation time and also to reduce the sound pressure levels because of that heat recovery unit. In the end, we presented real concrete data referring to the CO2 emissions, referring to the energy consumptions. And we just gathered all the data in an efficient graph from micro to macro, from the simple classroom to the entire school. And thus you can apply this to virtually any other schools, of course, after you modify the parameters, the geometry. The essence is that this is doable. We treated 5 different cases without ventilation or thermostatic valves, with the ventilation on, but without thermostatic valves. In the third case, without ventilation, just the thermostatic valves at the radiators. The fourth case with ventilation on and with thermostatic valves. And the best case scenario, the fifth one, in which you have all this new system in place on our project design and a rehabilitated building. Now, what we have here, kilowatts per year. We have in blue heating energy, red the artificial lighting, and with green the mechanical ventilation. Of course, in purple, the total primary energy exchange in the final value, kilowatts per year. we are underestimating, I think, the importance of thermostatic valves. If you see in the third case scenario, you have a reduction in the heating energy and in the final total primer energy, 27%. If you look towards the fourth case with the ventilation on, yes, you lose some of that energy that you reduced, but you highly improve the indoor air quality. Indoor air quality that highly affects you while you think, while you work. So let's think intelligent and act at the root of the problems. We can see from normal CO2 emissions for a classroom that have reduced, and when you go to a macro scale, we can see some very good tons of CO2 that you can reduce per year. Also, if you are to look at the total cost, we are talking per school, there's not a big difference from when you have your school non-rehabilitated without anything applied. You have a general cost. It's an approximated cost on how much the energy cost at that time. 10,000 euros. And if you apply this measure, you go to 8,000 euros per year. You would say it is not a great reduction. But how I wish to emphasize this here, does the health of the children has a price? We are talking about the future of us. We are talking about the future generations. And we are talking about us. We didn't manage to have the best conditions, or I at least when I was a pupil. Maybe we can turn our attention towards the future. At that moment we presented that that our work was interconnected with some articles, that the work was being part of a national research project. And this is the final of the presentation. With my final conclusion is that join and engage, again, how it was said. Be careful to greatly emphasize the experimental campaign and also with the simulations. One cannot go without the other for the best result. And I thank you for your time.